Jasmine Bennett.
Here.
Jules.
Here.
Lauren.
Here.
Cameron.
Here.
Elizabeth.
Here.
Griffin.
Here.
Ashton already said hello. Harrison.
Here.
Okay, and then I see Kylie. Okay. All right, so hold on a second. Okay, so you took your first quiz of Unit 2, and many of you found it more difficult. Okay, that is to be expected. Okay. So you'll see as we go along, sometimes the quiz is not going to get what you wished you would have gotten. Okay, and that's because there's a learning curve to taking a quiz or a test in calculus. All right, the material starts to accumulate and become harder. Now, I give you the base foundation of what you need to know. So I give you the product rule, quotient rule, power rule, definition of the derivative, and I try to keep the questions along that format. But realize that some of the questions are there so that you can problem solve. Since I only see you 2 hours of a week, of any week right now, you think I can't show you, even in a normal class setting, it's impossible for me to show you every single type of calculus question, right? It's impossible for me. I can show you general types of questions, and I'm hoping that you retain that knowledge and then apply that knowledge, okay? That is really what you're doing. You're applying your knowledge. When you get to taking the AP exam, or if you take it again in college, all right, I am preparing you for a situation where you get into a problem and you can apply what you've learned. All right, so again, if you expect me to go through every possible type of question that you will see on an assessment, that's not going to happen. It's impossible. I can give you a good portion, but there's some questions you're going to have to problem solve. Okay? So I know, for example, one of the questions that gave people trouble. Let's see here. Right? I'm going to look at one of the questions. Oh, give me a minute while I pull it up. Yep, that's what I thought it was. Because the other class had the same type of problem with this question. And I'm going to insert a page, and I'm going to present my screen. So before we get into the chain rule, I'm going to give everybody a problem. Now, mind you, if you did not score what you wanted, remember that the retake policy is that you had to have scored below an 80%, and that is the highest that you can get on the retake, is an 80%. So there is a retake that will be due, and I'll talk about that once I'm done with this. All right, that's geometry. You don't want to do that. Okay, so let's give you a question. Nope, not that one. Yes. All right. Oh, man. I give up. I'm just going to do it by hand. I don't want to cooperate with me right now. Okay. Okay, so I've given you two curves. One is F and one is G. So let H, let's go, H is defined by G divided by F. And I'm going to I want you to find H prime of -4. Okay, so H prime of -4. All right, so I look at this question and I look at the problem and it says, given the function is a quotient and I have to find the derivative of the quotient. Okay, so the first thing is I need to do the quotient rule. So Mr. Hernandez taught me the quotient rule looks like this. Bottom, derivative of the top minus the top, derivative of the bottom over the bottom squared. Okay, so far so good. Then Mr. Hernandez also taught me what a derivative is. He put it into my head that a derivative is the slope of a tangent line. If the function is a line, then the derivative is just the slope of that line at that point. Okay, so we get to the first part, f of -4. How do I find f of -4? Mr. Hernandez did not teach me how to find f of -4. No, I did not. You know why? Because that is expected of you to find f of -4. I mean, I teach calculus, and I have to know, obviously, all the algebra, but I'm hoping you know the algebra. I don't have time to be teaching algebra and calculus. So just be ready for that a lot of questions rely upon you knowing your algebra. So I need to find f of -4. So I'm going to come up here. Oops, I'll write the other way. I'm going to write the equation of this line. Y plus 6 is equal to, I need a slope. So I have to rise 6 and run 2. So there's the equation of f. So now I have to plug in -4 for x. So I know f of -4 is -18. I'm going to put -18 right here. All right, so I'm just leaving some blanks. All right, now, then I get to g prime of -4. G prime of -4, the slope along g at -4. Okay, oh, again, Mr. Hernandez didn't directly teach me that, but I know from Algebra 1, this is a line. And to find the slope of a line, I just do rise over run. So I have to go down 4 and to the right 3. Down 4 and to the right 3. Okay, now I go to g of -4. Again, algebra that is expected of myself. G of -4 is 4. F prime of -4. So again, linear. I've already calculated that. That's actually 3. Okay, from here, again, just arithmetic. So let's see, 3 goes into 18 6 times. So that would be 24 minus 12 over 18 squared. 18 squared is 256. And obviously this will reduce, and whatever that reduces to. Questions on that? And I believe, again, on WebAssign, it makes you want to reduce. It forces you to reduce. When we get to an actual paper test, you would not have to reduce. Questions on that one? All right. So again, be prepared to see another similar type of question on your, hold on, to see another type of question if you have to take the retake. Was that you, Gina?
Yes.
Okay.
Have we? What is the? So I have to recall what the topic of the notes today might be.
Chain rule. Chain rule.
Chain rule. Oh, thank you.
Okay. Okay. Going to keep this the same thing, except I'm going to erase all the bottom part. I hope you have the information. Right? And because I'm going to erase all this. And now I'm going to define H as G of X times F of X. All right, so find H prime of -4, everybody. All right, any questions on how I got 36? So also keep in mind of some other things that vocabulary-wise you have to be able to recognize. If the question wants where a function has a horizontal tangent would be where the derivative is equal to 0. If the question asks where there's a vertical tangent, all right, that would be where the function is continuous but not differentiable. So, for instance, so where does G have a vertical tangent? So a G would have a vertical tangent at the value where the derivative is undefined, but yet that the point exists on the original function. So the point is there on the original function, but the derivative at that point cannot be done. So let's take the derivative of this. All right, so the derivative would look like that, which, again, algebra. So look at your derivative, and then somebody tell me what value of x is the derivative undefined?
Equals 0.
0. Now let's check this out. At x equals 0, the derivative would be 2 over 0, which is not possible. However, 0 is a point in the domain of the original function. Like g of 0 is 0, but the derivative at 0 does not exist. So that's going to lead me to the conclusion that there is a vertical tangent along 0. And that's what happens if you were to actually graph x to the 2/3. It's one that looks like this. Looks like a bird. And then right at 0, there is a vertical tangent. Okay, questions on that? Your corrections for the quiz, everybody has to do corrections, irregardless. It's part of your grade. The corrections are due by tomorrow. Okay? So make sure to start those today. No, not right now, because I have to go over the chain rule. But they will be due tomorrow. Shucks. Okay. What else? You have a retake that is due by next Thursday. Okay. So you have three things, actually. You have the corrections are due by tomorrow. You have the retake, which is due by next Thursday. And you have quiz number 2 of this unit that is due by next Thursday. Questions?
I think this would be beneficial for, so I was gonna ask in Learning Lab, but so I'm like totally okay with like I understand like learning like the easy or like just like the basics in class, but is there any like outside resources we could use, or like any like helpful websites kind of beyond what we have for like the hard problems and kind of what we'll see on the test and quiz?
All I can do, there's two things. I can do, I can see if I can find an old quiz that I can send out. Okay. If you want just strictly practice questions on doing certain rules, all you do is actually just Google it, and there's a lot of websites that give you practice on derivative problems. Another option some students get is they wind up going to the bookstore and getting one of those Barron's books or AP practice guides that has a lot of those questions. I think one that has a lot of questions whose questions are actually hard, they're not easy, I believe is the one that by Barron's. Okay, do you have that one, Kylie? Does it have a lot of questions in it?
Yeah, I got it like last week. So
okay, so if you look in the differentiation section, because they go by sections, there are normally a lot of questions in that book. Okay, so I can see about sending out or practicing questions from an old quiz that I've made, or going online, or just getting a book from the bookstore, Amazon, anywhere. Okay. Okay, so today's the chain rule. All right, so your next quiz, not the retake, the next quiz, quiz 2, is going to have the chain rule on it. So now people ask, what's the main focus? I'm going to say the chain rule, but understand that you still have to use product rule, quotient rule, power rule. You still have to be able to look at a derivative and figure out, look at the definition of the derivative and figure out what's the function I'm asked to derive. So let's start with the chain rule. Okay, so you learn in Algebra 2 and pre-calculus, you might have practiced this, the composition of two functions. So for instance, if f of x is x to the 100th power, and g of x is the function x squared plus 1. Okay? And if I asked you to find, actually, maybe start that. Let h of x equal f of g of x. Okay? What would that look like? What would f of g of x? What's the actual process that you're doing? Somebody?
You put in like the whole g of x function into the x of f of x?
Correct. So this would look like this. Okay. So that you've practiced before. And now you get to calculus, and then you're expected to find the derivative of such a function. So think about that. Something raised to the 100th power. You're not going to sit there and FOIL it out 100 times. All right? You would be there forever. And the problem would be huge. So there's a workaround to finding this derivative. And here is the actual formula. So the formula says, take the derivative of the outside function, which I'm going to label as f prime. You keep the inside function. So keep it in there, and then you multiply by the derivative of whatever was on the inside. So I'll say that again. You have to isolate or figure out what is the outside function. Take the derivative of that. Keep the inside function. And then multiply by the derivative of the inside function. So if I were going to do that for this question, what's the outside function for this problem?
X to the 100th.
X to 100th. Okay, so the derivative of x to the 100th is 100 to the 99th power. Okay. The chain rule then says whatever was inside, you keep it inside. And then you multiply by the derivative of whatever that inside was. And I just clean this up. 200x times x squared plus 1 to the 99th power. That is your chain rule. It will follow you for the rest of however long you take calculus. The rest of this year, if you take BC next year, if you're off to college next year, you have to take college level calculus. This is one of the most frequently used rules. Okay, so let's try some other ones before we get to those notes. All right. All right, let's go. G of x is equal to the square root of, let's do 1 minus x cubed. Square root of 1 minus x cubed. Okay, so you see this question, it's got a lot of parts to it. You got to figure out what is outside and what is inside. So in order to help you with that, I'm going to rewrite this. Again, algebra, not me. This is algebra. Whoever your 7th or 8th grade teacher for algebra was, thank them or blame them. So 1 minus x cubed to the 1/2 power. So now I've figured out that the outside function is the 1/2 power. So I take the derivative of that outside function. Now my chance to ask somebody, what goes in that first blank spot? So there's 2 blank spots here. There's on the inside here, and then on the outside is something else that needs to go there. So what goes on the first blank spot?
1 minus x.
Yep, 1 minus x cubed. Okay, what goes on the outside?
The same thing.
Not the same thing. Careful, look where I got squared from. What's that?
3.
Negative 3x squared.
Negative 3x squared. Now, myself, I don't like looking at the negative in the middle like that. So I'm going to put it out front. Okay, now, again, Mr. Annette, what happened to my screen? Oh my God. Okay, let's try this. There we go. So now, just to practice my algebra, all right, because technically you could leave it like that. Practicing your algebra, this would become negative 3x squared in the numerator over 2 times the square root of 1 minus x cubed. Okay. All right, so let's take a look at some of the questions on the packet. Okay, so let's everybody. All right, we got to make yourselves. This is got to make you feel good about yourselves. Like, yes, I can do this. I'm not going to let calculus beat me. F of x is the quantity x squared minus 5 raised to the 4th power. All right, please find the derivative of that. Okay. I'm going to put the answer. If you do not agree with my answer, please be vocal. All right, so I'm not hearing anything from anybody. Okay. I'm guessing everything's okay with that. Let's jump down to one that's diagonal from it. Now, it looks like what is. This is a quotient. But you don't have to do the quotient rule for this one. In fact, it's easier if you don't. You want to rely upon your algebra skills. This is really 5x minus 3 to the negative 1/3 power. Now, if you did the quotient rule, it wouldn't be wrong. It would just look slightly different than the final answer that we're going to get. That is my dog trying to tell me the answer. Time to close the door. Sonny. Stop. Okay, I had a mute. I don't think that worked that well. Okay. Anybody want to try?
I can try.
Oh, I could. You want to try, Gina?
Yes.
Okay, tell me.
Wouldn't it be -5 over 3 to the 5x minus 3 cubed to the 4th power?
To what power?
You know what? It's to the power of 4 over 3.
Like that?
Yes, but if you put it in like if you don't want it to be like some negative exponent, you can put that equation of 5x minus 3 and that thing on the bottom.
Okay, so what you're saying is if I were to rewrite this, you get -5 on top.
Yes.
3 over here. Now, down here, I know I have to have a 5x minus 3. It's just a matter of remembering where the 3 and the 4 go.
The denominator is usually what number of the square root is. In this case, it's a cube root.
Yep, that's correct. It would look like that.
Yeah.
All right, good job.
Bye.
I hope you don't leave.
No, I am literally not leaving.
Okay.
My work is all here.
Awesome. Okay. So, as I was saying, this material accumulates like a snowball. It just keeps on packing onto itself. So not only do you now have to know the chain rule, but you have to have the ability to do the chain rule with a product rule, the chain rule with a quotient rule. Can you do a quotient rule within a chain rule, or is there a product rule outside the chain rule? So you have to make a determination of like, what's the overall rule being used? If you look at this question underneath, it says evaluate. The overall structure of the problem is a product rule problem. So overall, it's product rule. But within the product rule, you will wind up doing the chain rule. So let's take a look and see at this question. So I kind of split this up here. So the product rule says, first one, derivative of the second plus the second one, derivative of the first. The derivative of 2x is 2. Okay, so that blank spot that I have there is for the derivative of the square root of 1 minus x. So I'm going to do that work over here in red or to the left. Okay, so I need to take that derivative. So I come over here and I do 1/2 1 minus x to the -1/2 times -1. All right. Now, at this point, you're copying this down. Please. Okay, so I'm going to write that down. You look at it. You're going to look at this, and you're going to say, okay, I understand everything where he got stuff from. Or you're going to say, Mr. Hernandez, where did you get that negative from? Where'd the 1/2 come from? Why is there a 2 on the second one? You've got to stop and look at it. Enjoy the beauty of the mathematics. I guess everybody's okay with this. Okay.
I have a question.
Yes, Harrison.
Where did the negative come from in front of the 1/2? That one.
Yeah. Okay. So back up here, when I did the chain rule, Harrison, I took the derivative of the inside, the derivative of 1 minus x is -1, which is
All
why
right.
you see it out in front here and right there.
Okay, thank you.
Anybody else? Okay. At this point, look what it says. It says find f prime of -3. So I'm going to plug in -3 in for x. Now, sometimes I will jump some steps. You don't have to. And, you know, again, I'm not dumb. I realize most students pick up a calculator and try to do it that way. But just realize, like, this is really a non-calculator question. Okay, so everybody, again, take a step back, look at the problem, look at the values. If you have a question, where'd you get 3 from? Why is it 4 to the -1/2? How did you get 11 over 2?
Where did the 4 come from?
Which one?
For like the final.
This one?
Yeah.
Okay, the square root of 4 is 2. 2 times 2 is 4. Okay?
No, just like why did you plug in a 4?
Oh, I didn't plug in 4. I plugged in -3, but 1 minus -3 is 4.
Oh, so you just okay.
Yeah, I did the arithmetic in my head and just wrote it down.
Okay, I see now.
Anybody else? Okay. So the plan of things is we're doing chain rule today, and we're going to do more practice problems tomorrow. So you're not learning anything new topic-wise. You're going to see some different types of problems. So like I haven't done any trig ones yet, but we will get to those. All right. I just kind of want to expose you to the different types of chain rule problems you're going to see. Here's another type of chain rule problem where you're not actually given the function itself, but you're given specific values of the function. So let's look at f of x. Okay, so f is equal to g of x squared. So I need, again, this is one function inside of another function. So I need to do the chain rule. Okay, so anybody want to try telling me what the chain rule would look like for this one? You can always just type it in the chat as well. But I need some interaction. Otherwise, I feel like I'm Tom Hanks in Castaway. Some of you might not even know what that movie is. Anyway. Kylie's like,
would it be 2 times g of x times g prime x?
Thank you. That is correct. 2g of x times g prime of x. And then what's the value? 4? Okay. So let's substitute in. G of 4 is 4. G prime of 4 is -2. My answer is -16. Okay, so you're going to try the next two, okay? Once you have a specific value, please type that into the chat. No answers in the chat yet. Okay. Okay, so for the first one, I'm getting some different answers. I can't tell, like, when you put an answer in, normally you want to go 1 and 2 or something like, so I can distinguish between the two. So I'm going to wind up doing the first one. Right, so there's the first one, 5/6. All right, some of you are still doing the second or the last one. Okay, look at the third one. All right, look over my math. See if you have a question. If you feel like I made a mistake, let me know.
What happened to the g of x?
Okay, so g of x stays on the inside and the derivative of g of x goes on the outside. Now, I plug in 4. What's g of 4? So like if I were to write this out, it would look like h prime of g of 4 times g prime of 4. Well, g of 4 is 4. And then h prime of 4 is 5. So whoever had that question, does that make sense?
Yeah, that makes sense. Thank you.
Okay. Right. But you can't assume there's a power, because some functions don't have powers, as I'm going to show you right now. All right. That's why we just represent it with that little apostrophe to represent derivative. So for instance, I'm clicking on it and it's a little slow. Let's say I gave you y is equal to cosine of 100x. Cosine doesn't have a power in that case, but the chain rule still applies because it's not just the cosine of x, it's the cosine of 100 x's. So what is the outside function, anybody? Yeah, so now I take the derivative of the outside function. I'm going to write dy over dx. So the derivative of cosine, you hopefully have these memorized, is negative sine. You keep the inside part the same. And then you multiply by the derivative of the inside function. So my answer would be negative 100 sine of 100x. So the trig ones sometimes can be a little bit trickier because of the way things are written. So let's change this one. Let's do a different one. Let's go y is equal to sine cubed of x. Okay, just like some of the other questions, I'm going to rewrite this to help you. All right, so see how you get the sine of x. The quantity is cubed. That's how you rewrite this. And then you can see what's outside and what's inside. The outside function would be what? Dramatic pause.
X cubed.
Cube, yeah, x cubed, the cubing. So that would be 3 times something squared. So what goes on the inside was what was originally on the inside. And what goes on the outside is the derivative of sine, which is cosine.
I have a question.
Mm-hmm.
For the final answer, would you put cosine in front? So it would be like 3 cosine of sine x squared.
You don't have to. You
Okay.
can just leave it like that. Doesn't make a difference because of the properties of multiplication.
Okay.
Okay. Next one. Y is equal to 4 times the secant of 3x. All right, so everybody try. Okay. I'm about to send the answer in the chat. Here goes. Now, I'm going to guess some of you did not have that. Yep. Arnav's like, nope. Arnav, can I just use you? I'm not picking on you. I just want, what did you have written down?
I mean, I didn't do it yet, but I mean, the answer looks pretty scary.
And did anybody try it and get a different value?
I did.
Okay, Ashton, what did you get?
Well, I didn't know what to use as the outside, so I used the 4, and obviously the derivative of 4 is 0, so that wouldn't work.
Okay. Well, that's a good question. Every year people think that. They think because the derivative is 4 of 0, then is the answer 0? Okay. So that's one thing that's a good point. Again, I get that every year. The thing is that the derivative of the constant is 0 only if the constant is going to be by itself. So if I just have y is equal to 4 and nothing else, then that derivative is 0. But if I have 4 in front of whatever, who knows, whatever function is after this, the 4 is just going to stay there. It's called a scalar. It's really just making the problem bigger. Okay, so the way I did this question is by doing this. I keep the 4 because I just said it's a scalar. It's not going to go away. It's just going to get multiplied back into the problem. Then I do the secant. And everybody has the derivative of secant somewhere in front of them or has memorized it already. The derivative of secant is secant tangent. So the outside function is really secant. So the derivative of secant, as I just said, is secant tangent. Now notice I left the space because the chain rule says you have to keep the inside function there. You can't get rid of it. You can't change it. So often what I see is people don't write 3x. They just write x for whatever reason. They just think that they sell x in the original derivative. But it's like everybody gets a fair share in the derivative. So the 3x has to come up twice because that's the way the derivative shows up. And then the last thing is the derivative of that inside is 3. So that's how I get 12 secant 3x tangent 3x. All right, we got about 5 to 6 minutes, so we're going to try another one that's similar to this so that you get the idea of what's going on. Whoa, where did my pen go? Okay. All right, there is the function. Let's see, how many minutes does it take you to do a derivative? 2? 2 minutes? Okay, let's see. Just be careful, Keon, when you write it like that, because it looks like you're saying 16 minus. Okay, so I think everybody's getting the idea from that prior question of how to write this. Yes. Yes. Okay. So keep in mind that these problems, you know, you have to be able to look at a table and do them. You have to be looking at a graph and be able to do them. All right. Let me just see. So what, okay. This works. Okay, so we're going to finish up. I know it's 10:24, but we'll go a little bit over. We're going to do one of these questions. All right, this is in the chain rule packet, the first multiple choice question. All right, so that you can see where you have to look at some values. All right, and find the derivative. So you see this question. What rule, which of your derivative rules is the overall rule for this question?
Is it product rule?
Correct. It's product rule. So sometimes with a product rule, what I do, I tell students or I teach them to do is to keep themselves organized. Right? I come to the right over here. I'm going to write the two functions, but with a bit of a space between them. Okay, so I'm going to do that. And then I make a small table. And underneath each one, I'm going to put the derivative. So the derivative of x is 1. Now here's what you learned today, the derivative of the second function. Anybody want to try telling me what's the derivative of the g of h of x? What would that look like? Yeah, what's the derivative of the g of h of x? So like my arrows are pointing to the derivative. What would be the derivative of the one on the right?
G prime of h of x times derivative of h of x.
Correct. G prime of h of x times h prime of x. Okay. So I can set this up because it says you take the first one, multiply by the derivative of the second one. And then plus the second one times the derivative of the first. And then you plug in a 3 wherever you see x. So I'm going to do that above it. Oops. All right. Okay, so again, I'm just looking at the numbers above. H of 3 is 4. Then I have G prime of 4. So G prime of 4 is 3. H prime of 3 is -2. And G of 4 is 2. So -18 plus 2 is -16. Okay, so what I'm going to give you tonight was just for you to do your corrections. There is a Delta Math activity if you want to start it. It's got several questions on the different topics that we've covered in this unit. Okay, if you want to look at that and start that now, tonight, feel free. We're going to work on it tomorrow as well. I will look to find an old quiz. Okay. Any questions on what we did so far, or any other questions? Oh, silence. Okay. Well then, I'm not going to force you to stay. You can leave if you want to. Anybody else, feel free to stay, and we can practice some other questions in one of these packets. So when I get my remaining people, then I'll find a problem.
Mr. Hernandez, I have a question.
Yes or not?
So the one that we just did, like that one. So why is this, I get the first part here, like that's just
Which part? My setup over here?
part, like second plus.
What's that, Arnav?
Yeah, set up on the left-hand side of where you're talking about +1 g of h of x.
Yes.
When you're actually doing the, yeah,
Derivative.
why, like, I'm kind of like, I just got lost at that point.
Okay, so in the product rule, right? I'll change my colors. So the product rule, one way of setting it up is just to make a table. Because in the product rule, what winds up happening is you wind up multiplying like the two functions that are diagonally from each other. And the big cross reminds you to add them. Okay, so that's all I did there. So I took the x and multiplied it with the derivative of the g composition.
Oh, okay.
And put a plus,
Okay.
and then reversed it the other way.
Oh, got it. So you just put the derivatives of each of like the values under him, so then you just multiply.
Yeah, it's kind of just for organizational purposes.
Okay, thank you.
Oh, it's probably because of the settings that I have on. Let me go check.
It says that for me too.
All right, let's check this out. Schedule. Okay, so try looking at it right now. See if you can see it. Maria or Keon, are you trying that? Maria?
It still isn't letting me.
Try refreshing your page.
Yeah, I refreshed it, but it's still under like current assignments. But I mean, I did the quiz.
Oh, I know why.
Okay.
No, if you click on it, it shows you the answers.
What's that?
It shows up under current assignments. It's just if you click on it, you can see which ones you got wrong.
Yeah, it's working for me too.
Okay. So if you go into it now, will it do it?
Yeah, I can see what I got wrong. Thank you.
Okay. Okay. So anybody else left here? let's look at one of these questions so you can practice your chain rule. Let's not do that one. Okay. Here we go. This is on the last page. It says the graph of a function f shown below consists of 3 line segments, and g is a function whose derivative is f. All right, g is a function whose derivative is f. So looking at A, so what does that actually mean? G is a function whose derivative is f. How would I write that out? Anybody? Important to be able to read and figure out what is that saying. G is a function whose derivative, so the derivative of who, G or F?
Wait, are you sharing your screen?
Oh, yeah. Sorry. I was, thank you, Avi. I forgot. Here we go. It's on the last page. There we go. So in this problem right here, it's on the last page of the notes. It says, suppose G, so you're given F, and this happens a lot. You're given one graph, but they're talking about a different graph. So suppose G is a function whose derivative is F. So the way you would interpret that is G prime is equal to F. Because it says G is a function whose derivative, so the derivative belongs to G, is F. Okay, so look at question A. Suppose y equals x plus 7 is the equation for the line tangent of G at x equaling -3. So remember I said a lot of this is being able to decipher what is it that they're trying to tell you. So when I read that, I pick up on some things. This y equals x plus 7 is the tangent. All right, that's the tangent of G. So that would mean that G prime of -3 would equal what?
7?
Not 7, because it's saying that x plus 7 is the line tangent. Remember what a derivative is. What is a derivative?
Slope of the tangent line. Is
It's
it
the
1?
slope of the tangent line. So what would be the slope of the tangent? 1. Okay, so now it's asking what's h prime of -3. So I have to do the chain rule. So we did one similar to this earlier. So you drive the outside, keep the inside, and multiply by the derivative of the inside. Okay, so G prime of -3, I know that is 1. How about G of -3? How do I figure out what G of -3 is?
Just look at the graph.
No, you can't look at that graph. So the idea is when a curve and a tangent touch each other, like right at the picture that I'm showing, two things are happening. One is that the derivatives have to match. So the slope of the line is the slope of the curve. The other thing that has to be true is that they share the same x and y value. Right? Because they're touching each other, they're coexisting at the same point. So even though I don't have the curve itself, I have the line and that specific x value. So that should be 4. So the answer would be 8. Whoever designed this question, I didn't design this, I just found it off the internet, did not set this up the best way because it's misleading from the instructions. I'll let you know that. The AP style questions that are like, they're checked so many times. I mean, they're checked at least 5 to 6 times by people so that anybody can pick up on a mistake. Okay. Let me look around, just make sure we can try one more of these things. All right, so yeah. Okay, we'll do 13 and then we'll call it a day. It says write the equation of the tangent line and the normal line at the given point. Okay, so how do I find the tangent line equation? What do I have to do? Yeah, I have to find the derivative of that, correct. All right, somebody want to try telling me? If I'm looking at it, just tell me what to write.
Isn't it just x squared minus 9 to the 1/2? And then you just use the power rule? Or do you have to use the chain?
So Avi, tell me what to write.
Oh, first it'd be x squared minus 9 up in parentheses to the 1/2.
Which I have right here.
Oh, okay, yeah. And then the 1/2 goes in front and it goes to the negative 1/2.
And then?
Oh yeah, times, it would just be x, so it'd be 2x.
There you go. There's your derivative. Now, what number am I plugging in for x?
5.
5.
So this would become 5 times 16 to the negative 1/2. Again, I skipped some algebra arithmetic steps. Like, what happened to the 1/2 and the 2? Well, the 1/2 and the 2 cancel each other off. So it just leaves me x, and that's how I put the 5 in front. And then 25 minus 9 is 16. Okay, so the remaining people, who wants to help me out? The first one I'm going to write is the tangent line. What would that look like? Well, somebody knows it's got to be an equal sign in there, and I know there's got to be a y and an x.
The slope is 5/4 before the arc.
Okay, and the x value is
minus 5. Yeah.
And then the y value would be?
You plug 5 back in the original equation.
Correct. And that would be 4. And then we have the normal line. How's the normal line different?
The slope is the reciprocal of the tangent line slope.
Right. Negative and the reciprocal. So negative 4 and 5. Okay. Unless you have questions, you're free to go. Remember, you go work on your corrections that are due by tomorrow.
Yes, sir.
You're welcome.